Hi, everyone. I'm Kirsten Newcomer, Director of Security Product Management for Hybrid Platforms at RedHat, with a focus on container and Kubernetes security. So I'm here to talk today about zero trust and supply chain security and how to use these together to really improve your security posture management for your Kubernetes environment. So let's start with a quote from Wendell Snyder, Chief Security Officer, Fastly. One single vulnerability is all an attacker needs, right? We have seen this repeatedly. This might be a newly discovered vulnerability. It might be a vulnerability that's been around for a while, but the server has gone unpatched. But we see that when these are taken advantage of, right, it can lead to significant data breaches that are very costly for organizations, both in terms of revenue and reputation. So the reality is that security is a business level conversation. The information on this slide is taken from a regular survey that we do at Red Hat, the State of Kubernetes Security. This is from the 2022 survey, and you'll see that 55% of our respondents have delayed or slowed application deployment into Kubernetes due to security concerns. Now, oftentimes that might be their most sensitive applications. It's not that they're not using Kubernetes. It's just that they're slowing down or being very selective about what they deploy. Similarly, 31% of our respondents have mentioned that customer or revenue loss have been impacted due to a security or compliance issue. So really, and the most common types of security incidents they're running into: detected misconfigurations. Now, this is by far the largest, and it's not surprising given that the large number of Kubernetes components that need to be deployed and configured, how those interact with the host operating system, and then that on top of that, right, you have to manage the configuration of the applications deployed to Kubernetes. Second most popular or most common issue is having a major vulnerability to remediate and needing to manage that across the platform and the applications deployed to the platform. Third, a security incident at runtime. Fourth, a failed audit, whether that's for security policies, regulatory compliance, and then the lucky 7% who have not had any type of security incident. So there's some bad news and some good news out there, right? We're seeing that supply chain attacks are increasing. Now, there was a saying a number of years ago that we used to hear in the field that open source is eating the world. Well, pretty much these days, almost every solution developed and deployed software solution really includes some open source. And so we can see from this data from our friends at Sonatype in their State of the Software Supply Chain report from 2021 that supply chain attacks are increasing by significant amounts, 650% year over year increase in 2021. That said, there's also a great deal of security research focused on the most popular open source projects, right? So the most popular open source projects tend to have the most pervasive vulnerabilities or the most vulnerabilities. However, that's really that's good news. That means they're getting attention, they're being discovered, and once they're known, they can be addressed, right? So this is, while the stat may be a little disconcerting, it's actually positive because we can address these issues once we know about them. So given the reality that there is no such thing as 100% security in the software world, let's talk about how zero trust and defense in depth can be used to help protect your Kubernetes and containerized application deployment. I want to start by saying what I mean by zero trust, right? Zero trust has become really a buzzword in our industry, and different organizations or different content that you might read define it in different ways. So for this presentation, here's how I'm using the term. I'm making a distinction between a traditional security model, which has a certain level of assumed trust. That is, in that traditional model, the focus was on perimeter-based security. This might be for an on-premises data center, all the systems are managed in that data center. There's a level of assumed trust for individuals who have access to the data center and access from the organization to the solutions deployed in that data center. They're really focused on protecting against outsider threat. A zero trust model, on the other hand, assumes no implicit trust. It starts with the concept of deny all by default and verify all. So authentication and authorization is required between all parties and is informed by identity and integrity solutions, and then also some additional protection is added via isolation. So zero trust and defense in depth really work together. Zero trust, again, about tightly managing access, the identity of individuals, the identity of human actors, the identity of machines, and applications, but also the integrity of the environment, right? How is access protected? And defense in depth is about creating boundaries, and those boundaries are the places where proof of identity is required. Also ensuring that you have controls at all layers of your stack, right? A stack includes the platform, the data, both the platform data, application data, your infrastructure, your network, devices, identity. You want containment, you want the appropriate controls for all of those elements, and you want to provide the appropriate isolation between different layers of your solution or different elements or different places in your cluster. And finally, observability is key for defense in depth, right? You can't secure what you can't see, so you need appropriate observability for fast detection, response, and remediation in case an issue occurs. So let's step in and talk a little bit more about identity, starting with user identity. So standard user accounts, right? That's the primary way that humans get access to a Kubernetes environment or to the applications running on Kubernetes. It's really important that you have tight control of your of your identity management system, your identity provider, with robust policies, right? So ideally, you want to be using an identity provider with Kubernetes that offers two-factor authentication. You also ideally want that for your applications that are running on top of Kubernetes as well. That ensures that if usernames and passwords are stolen, somebody with that data still doesn't have enough information to actually get access to the solution with that username and password. You also want to think about cluster access and application access as separate layers. Just because a user has access to the cluster does not mean they should have access to the applications running on the cluster. Similarly, just because a user has access to an application doesn't mean that they should have access to the cluster. So you want to be thinking carefully and managing those separately. Now, if this is all internal use, your cluster users and your application users are all part of the same organization or enterprise, you may want to have kind of a federated approach that helps manage user access to those two different layers. But that's really for the scenario where it's all users from the same organization, right? And in many cases, we're talking about applications that provide access for external users, such as a banking app on my phone. When it comes to host access, again, you want to tightly manage access to that host operating system. All of the servers that are part of your Kubernetes cluster should only be used for Kubernetes, right? So that helps you ensure that you really think carefully about the configuration of that environment. That host is designed just to support Kubernetes. You have a very small number of users who have access, and really the only access is for patching or for other kinds of break glass scenarios that you might need. And across all of these layers, the host, the Kubernetes, and the applications, you want to minimize privileged access using role-based access controls. Now, workload identity is especially important in a Kubernetes environment. Kubernetes is designed for automation. Everything is API driven. So the primary or a typical way to represent identity for an application in Kubernetes is with a service account. With that in mind, ideally, you will be using a separate service account for each application. That ensures that you can have solid traceability between activities that happen in that application and the service account, rather than sharing a service account across apps. Also, if your solutions, whether that's Kubernetes or again your applications, have integrations to public cloud services such as AWS or Azure, you want to be sure that you are making those connections using the cloud services identities and ideally using short-lived tokens. Again, best practices. Now, if we think about applications again, we take another look. There are solutions out there, frameworks like Spiffy and Spire, available that help provide attestation for both nodes and applications, right? Attestation is a way of saying, I can assert and verify that this node is is the node I think it is, and that this application is the application I think it is or it says it is. Attestation typically is tied to having a hash or other cryptographic, data that represents the node or the application. That hash is stored somewhere, and that hash can be used to verify that the node or the application is still in the same state. So if you're using service mesh like Istio uses Envoy to fetch cryptographic identities from Spire to authenticate services with each other. Again, so another way to ensure that I've got workload identity. Taking a look at integrity, again, we're going to be thinking about integrity in a new way as well, right? So identity, integrity, again, very common overlap in terms of this concept of cryptographic identity. So if the hash hasn't changed, not only does it tell me it's the same kind of application or host, but it can also tell me that nobody's tampered with it, right? So when we think about this at a host layer, it might be the same server, but maybe a patch has been applied. In that case, the cryptographic identity for that server is going to have changed. So we want to move in this new world, in this cloud native world, from kind of manual change management processes to processes that enable attestation in an automated fashion and checking of integrity and controls that are implemented as automated policies for continuous verification. So at the host layer, one of the ways we look at host integrity again today, you can use secure boot on a Linux host to ensure that a trusted, unmodified kernel is loaded. You can use a solution like Advanced Intrusion Detection Engine, or AID, to monitor the file integrity of the files on that host system and detect system intrusions. And again, AID is going to use cryptographic hashes to kind of monitor the contents of directories or files on that host system and alert you if an unexpected change has been made. You can also, of course, take advantage of encryption to protect against theft of a disk. And you can encrypt the etcd data store as well to, again, ensure that you are protecting against unauthorized access by somebody. You want a platform, a cloud agnostic implementation. You can also, for the host, leverage a solution like Clevis and Tang today, which allows you to do automated decryption. Remember that, in a kube world, if a host goes down, a node goes down, you want it to reboot or add a new node. You want to be able to have encryption in place and automatically decrypt when the system is booted. And Clevis and Tang allow you to do that. So the next level of integrity for the host is enabled with Keylime. So this is an open source project that's a lot of work has been happening in this space for quite some time. It supports, just like we were previously talking about, remote disk encryption, where keys are managed off cluster and you can do automated decryption. Now we're talking about remote attestation. We can encrypt payloads, we can track changes to those payloads and ensure that we are continuing to capture a hash of those changes. And we can have a root of trust that is a TPM or a virtual TPM. And if something changes that is not expected, an unexpected change happens, we can check the attestation server. And if that is not an approved or logged change, we can automatically revoke trust for that server. All of this enabled through Keylime. If we take a next kind of step up and we start thinking about container images and applying the same concept of attestation, we can think about images both for the Kubernetes layer and for the applications that are being deployed to your Kubernetes environment, right? So you want to use, whether you're building for Kubernetes, building Kubernetes images themselves, or building an application that you're going to be deploying on a containerized environment on a kube cluster, you want to be sure that any external content is coming from trusted sources. You want to be sure that if you are including a base image, that base image is signed and that you can verify the integrity of that base image before you consume it, right? Ensure that the hash for the image at its source is the same as the hash when you have received it at your download location so that you know there was no tampering in between. You want to store this content in a trusted private registry. You want to automate your CI/CD pipeline to enable rapid updates. Again, when we think especially about the applications deployed on your Kubernetes cluster, right? Never patch a running container. Why? Because that patch can be lost. You always need to rebuild and redeploy. Again, Kubernetes is going to monitor if you've said you need 3 instances of your pod running at all times and one of those pods goes down, Kube is going to notice, it's going to redeploy from the container image. So if you patched that running pod, you now have lost that patch. Again, rebuild and redeploy. That means you really want to be automating your CI/CD pipeline. You also want to be integrating security tools and gates in that pipeline. Now, scanning for known vulnerabilities, that's a common thing. Most people are doing that. Up your game by scanning for application misconfigurations. Scan your deployment YAML, scan your Helm charts, look for excess privileges. And then finally, again, think about how do you validate the integrity of the content that's been produced by your pipeline. You want to ensure that all the content that's been produced is signed so that any consumers, whether they're part of your organization or an external organization that's going to download your content, can validate the integrity of the content from your pipeline. Now, there's been a lot of attention to supply chain security that goes beyond what we've just talked about, right? There's this new organization that goes by SALSA, supply chain levels for software artifacts, right? This is guidance, new best practice guidance in the industry for how to ensure the integrity of your application supply chain. And it talks about adding signing and attestation at a range of places within your supply chain. And it also includes a number of other things that you really want to be doing for good supply chain security. Now, SALSA 4, right, this represents the ideal state. It's going to take organizations time to get there. And so with that in mind, the group working on SALSA has recognized and identified 4 different levels to provide an opportunity for folks to take incremental steps along this journey. Okay. And when it comes to signing content as it moves through the supply chain, this has been kind of an issue that's been a bit challenging for us as an industry to solve, right? If I flip back here, you can see we want to be sure that we have verified history of source, that we have non-falsifiable provenance. All of these things rely on signing. But typical signing solutions such as PGP aren't easy to use in a pipeline environment. Here are a number of the reasons that make it challenging, right? Security of private keys is challenging to manage. The standards that are available are complicated, sometimes hard to understand. Tools aren't easy to use in a supply chain. Revocation inconsistently done, identity key pairs shortcomings. And so again, the upstream community has been investing in solutions to help address this challenge. So Luke Hines at Red Hat founded the SigStore project, which has many more contributors besides Red Hat. And this is designed explicitly to help with management of attestation and integrity of content as it moves through the supply chain. SigStore has multiple elements. Ways to do signing is one of them in a fashion that's easy to integrate with a CI/CD pipeline. Also, non-repudiation, right? There's and signature storage, as well as additional timestamps. So this is not a SigStore presentation. I hope that perhaps you'll have found one. Another one might be offered during KubeCon days, but if not, there's lots of content on SigStore available out there on YouTube. Go and read up about it. But next, we're going to talk concretely about how SigStore can be used in a Kubernetes-native supply chain to ensure security. And let me also mention that the Kubernetes community itself has adopted SigStore for signing content and artifacts that are produced out of the Kubernetes projects. So we have a number of upstream projects that are part of this supply chain security process here. The key thing here is Tekton. Tekton is a Kubernetes native pipeline tool. It allows you to define pipelines as code, deploy them as code, move a pipeline easily since it's designed as code from one cluster to another, stateless, etc. We're also going to be talking about the role SigStore plays, the role of a private registry such as Quay, the role of a security solution such as StackRox and Tekton chains. So kind of let's walk through this a little bit, right? One of the things you want to be thinking about is when you're working with your source code, what are the tests that you want to be doing early on with your source code? That should include a dependency scan that identifies a bill of materials. And you might do that with an open source project called SIFT or another called ScanOSS. I'm sure there are others out there, but good open source tooling available to you for producing an SBOM from source code. Once you've got your image built, you also want to do a vulnerability scan. You can use StackRox for that. You can use Trivy. Again, other open source scanning projects that you might want to take advantage of. Now, once that image is built, you want to store it in a container registry, whether that's Quay or some other registry. And you want to sign the image and store the signature. So again, SigStore comes into play here. I can use cosign to sign my image. I can store both the image and the image signature in Quay. Once I've created my deployment, whether that's a deployment YAML, a Helm chart, I want then to do my app config analysis. Kubelinter is a great open source project available for you for doing that, looking for misconfigurations in that content that you want to find again before you hit deployment. Ideally, you'd be signing your deployment files as well. And again, you can use SigStore for that. Then I might go through integration testing, user experience testing, user acceptance testing. Some organizations may want to add another signature to the images to indicate that they've gotten through these stages. And ideally, I am storing the record of all of these signatures in the recourse signature log, as well as having those signatures associated with the image in Quay. That means that when I am now ready to deploy to production, to deploy to my Kubernetes cluster, I can use an admission controller to validate the signature on my image at deploy time. And if the signature is not recognized, the pod or the deployment will not be admitted. So if we move on from integrity and attestation, I'm sorry, I forgot. One of the other key things here in Tecton Chains is I want to be sure not just that my content has been attested to, but that the actual steps in my pipeline have been attested to. And I can use Tecton Chains to do that, to ensure that when I have deployed my pipeline, and as things are moving through the steps in my pipeline, that the actual pipeline steps have not been tampered with. And again, actually, can't believe I forgot it, because that is one of the greatest advances that we have in the Kubernetes supply chain security story. The combination of SigStore and Tecton Chains for attestation of both content and the pipeline itself. So when it comes to isolation, now we need to think about how do we minimize the blast radius if something does happen in my environment. I've applied zero trust principles, I've applied defense in depth, and yet something does happen. So how do I minimize the blast radius? Kubernetes has come a long way in this space. And kind of as it's been more and more adopted, we see more capabilities that help provide isolation. So we want to use a combination of role-based access control, Kubernetes namespaces, and Kubernetes network policies to isolate applications across teams, groups, departments. So in this graphic, we can see that we have 4 namespaces on a single cluster. This particular user in the center of the graphic has access to the payment dev namespace, but does not have access to payment prod, catalog, or inventory. Now, truly, in most environments, any development is going to be done on a separate cluster from my production cluster, but just let's stay with me for this example, right? You can also see that network policies are in place that help to ensure and manage communication between pods in the cluster. So by default, in payment dev, all of the pods deployed to that namespace are allowed to talk to each other, but they're not able to have any communication with pods in any other namespace. So this is also true for catalog and inventory, with one exception. And this shows the power of Kubernetes network policies, right? I can start with a simple configuration of network policies that says every pod in a namespace is able to talk to every other pod, and then I can tighten that. I can tighten that by saying, in this case, I need this pod in catalog to talk to that pod in inventory, but I'm only going to allow that on port 8080. It is absolutely denied on port 5432. So again, fine-grained microsegmentation available to you with network policies. We can also add additional capabilities with SE Linux mandatory access control. We'll talk more about that later. So we also want to be thinking about encrypting communications, again, to ensure that nothing leaks in transit. When we talk about Kubernetes network policies, that's about managing east-west communication in your cluster. We also need to be thinking about north-south communication. You want to use secure ingress routes to your applications and egress IP and egress firewalls when communicating off cluster. You also should consider having a separate load balancer in front of your control plane or your master nodes from the load balancer in front of your worker nodes and your applications. Again, separation of concerns here. When it comes to egress, again, you may need to talk to an off-cluster database, and you want to be sure that that is securely and carefully handled. Maybe you've got a firewall in front of that off-cluster database, and you need something like an egress IP service to help manage that. For pod-to-pod communication, again, while network policies can provide that fine-grained control, you might also choose to use a service mesh like Istio with Envoy to encrypt pod-to-pod communication. That also gives you a different level of control for your pod-to-pod communication. And at the host layer, IPsec is available for encrypting node-to-node communication. Additional runtime isolation can be provided with a number of capabilities. So There are a lot of Linux features that support isolation, right? You get, in addition to Kubernetes namespaces, we have, of course, Linux namespaces, C groups, user namespaces, and we have solutions like SE Linux, or if you're on a Linux system that doesn't support SE Linux, AppArmor. So SE Linux has demonstrated the ability to mitigate or prevent container escapes to the file system. SE Linux provides multi-layer security and mandatory access control, huge value add for minimizing the blast radius. There may be cases where you want additional isolation, and this is where solutions from the community like KubeVirt and Kata containers can be helpful. Now, KubeVirt allows you to run a VM in a pod, so you still have your Kubernetes control plane with the ability to run that VM. This might be most appropriate for a lift and shift sort of environment where you need a full-blown VM. Kata containers, these are micro VMs that add the additional isolation of virtualization to your container, but it's not for a lift and shift, right? This is more for a containerized, a cloud-native solution. Note that both KubeVirt and Kata work best on bare metal, right? You want to avoid nested virtualization, which can cause, challenge, can make it difficult to debug certain situations, right? And here are some links that show how some organizations out there today are using some of these features with Kubernetes on bare metal. Next, observability. Again, you can't secure what you can't see. Monitoring and audit logging all are key. So let's start there. Those are the basics, right? Audit everything you can. Audit ingress. Audit your host events using a solution like AuditD. Take advantage of the Kube API server audit that comes with every Kubernetes cluster. Look at the level of audit configuration. Ensure that your applications as they are built are designed for monitoring, logging, and appropriate audit. Collect all your logs and forward them to a SIEM, a security information and event monitoring system, for alerting. You want additional analysis of that log content, correlation and analysis, to be done in the SIEM off cluster. You don't want the cluster carrying that load. And also for log integrity, you want to be sure it's forwarded off cluster on a regular basis. Speaking of log integrity, audit access to your audit logs. Right? So monitor who's actually stepping into those logs. Ideally, it should only be for API server audit. For example, it should only be the API server that's logging events into the audit log. Deploy a monitoring solution that can be used by both platform components and the workloads deployed on your cluster. Prometheus is very popular. And then also next, think about runtime analysis, right? There are multiple solutions, open source solutions available for runtime behavioral analysis. StackRox is one of those. Falco is another, currently part of the CNCF project. You want to be looking, runtime behavioral analysis does a couple of things. It takes kind of a baseline of the behavior of a running container, and then it continues to monitor for anomalous behavior or odd behavior, unexpected behavior. It also can help you identify privilege escalation, namespace or ownership changes, unexpected network connections, spawned processes using exec, shell binaries, SSH binaries that are actually executing. These are all things you want to be paying attention to. And again, you want alerting on these kinds of processes. You want to use an analysis engine that knows what to look for, has rules built in, and provides alerting capabilities. Which brings us to policy-based management, right? Again, highly automated environment, lots of moving parts. We want to be managing policy as code in an automated fashion. And the good news is that Kubernetes and related open source projects help us do this. So how do we think about policy in this environment? You need a policy administration point, right? A central management system for defining policies, an enforcement point that ensures that the current state matches the desired state, a decision point, that's your policy engine, right, that takes into account if the current state doesn't match the desired state, what are the decisions available to be made in that situation? And you also need an information point where you get additional metadata that helps to inform the policy decision that you need to make. And typically, that additional metadata is going to come via the Kubernetes API or other introspection of your Kubernetes environment. So we can look at policy-based deployment, policy-based runtime analysis as well. We talked about runtime behavioral analysis. Again, you want to be using a solution for that that has a built-in policy engine with rules on what to alert on and the option for the kinds of actions you might want to take. When it comes to deployment, right, if we want to kind of get some of these policies in place before we even get to the runtime to try and stop problematic workloads or problematic pods from being deployed, here are a couple of things you can do. Add an allow list and block list to your Kubernetes cluster to be sure that pods are only deployed from approved registries, right? You just want to be very clear. Again, ideally, you're using a private registry, not always pulling from public registries. And in that case, you only allow pods from your approved registry. And in fact, if your organization has multiple registries, you may have one that's specifically for production workloads. Make use of admission controllers. Validate those images that are signed with SigStore. Validate those signatures on admission using an admission controller. Take advantage of pod security admission, which is the replacement for pod security policies, to ensure that only pods with allowed permissions are deployed. If you need policies that are more complex than those that are supported by pod security admission, two additional well-used projects in the Kubernetes space are OPA Gatekeeper and Kyverno, which allow you to define more complex scenarios for pod admission. And then again, if we think about policy-based deployment, we want to be thinking about placement of our applications. This circles back to audit considerations, right? There are many places in the world that have privacy regulations that have statements about where specific types of data are allowed to be deployed. For example, personal data about German citizens can only be stored in data stores that are in Germany. And so that situation, that's a bit of an overstatement of the law, but let's just keep it simple. So in that scenario, right, you want to be using a solution like Open Cluster Management that helps you automate by policy where a particular application is deployed. More and more organizations are using multiple Kubernetes clusters, partly for locality issues. They might want one in Germany, they might want one somewhere else, partly for scale, right? And so Open Cluster Management is available to help do policy-based configuration and application management across multiple clusters. So another solution to take advantage of. Speaking of configuration management, again, policy is code, configuration is code. There are many configurations that you want to be making for your cluster. It's a wonderful element. You can declare the configuration for your app, for your cluster, take a GitOps approach to managing those configurations as well, right? Store your YAML files as code, version them, use a solution like Argo CD, a GitOps approach again to deploy those configurations. And also a solution like Open Cluster Management to monitor for configuration drift and to ensure that those configurations are deployed to the clusters you care about. So, in summary, evaluate your existing controls and look for opportunities to take incremental steps. I know I've covered a lot of ground here. There's a lot to think about at all layers, host, Kubernetes, and the applications that you're building that you're going to deploy to Kubernetes. Let's focus on Kubernetes and applications, right? There are a lot of things available at the host layer. So let's think about Kube and let's think about the applications, how can we improve automation of our CI/CD pipeline, take advantage of these new solutions, Tecton Chains, SigStore. Also at the host layer, look at Keylime, take advantage of what can be done there. And when it comes to and the additional features available for host integrity and observability and runtime analysis, again, key. As you look at what incremental steps you can take, again, best to start small, perhaps with a greenfield application. Set clear guidelines and expectations. Again, if the policy is written as code, that's good for people to be aware of those up front, and provide documentation and examples about what those policies are and how to comply with them. Be specific about the characteristics of the environment. What can you do in bare metal? Are you going to use KubeVirt or Kata? And keep the communication channels open, right? New technology adoption, it's not just about tooling, it's people, processes, and technology. And so we have to keep in mind the people element and always be sure that we figure out how to take an iterative approach, keep that communication channel open, and plan to respond to feedback. So thank you very much for your time today. And I look forward to hearing back from you all.